Welcome to Crisis in Perception, where we examine the systems shaping our world one book at a time.
All right, so today we're cracking open Jim Al-Khalili's The World According to Physics. Now, this isn't just another science book. You should really think of it as a user's manual for reality itself, the fundamental operating system that governs absolutely everything.
The book kicks off with this really deep problem. Our common sense, that gut instinct we rely on every single day, it totally fails us when we try to understand what the universe is actually like. I mean, it makes sense, right? Our brains evolved to survive on the savannah, not to wrap our heads around black holes or things popping in and out of existence.
So if our intuition is basically useless here, what do we do? Well, this is where physics comes in. Al-Khalili shows us that physics isn't just a big pile of facts to memorize. It's a system, a disciplined, rigorous system for testing our ideas against the world itself.
And at its heart, that system is actually pretty simple. You come up with an idea, a hypothesis. Then, and this is the important part, you test that idea against reality with experiments. And based on what you find, you tweak it, you refine it, or you throw it out and start over. It's this constant back and forth that gets us closer and closer to what's true.
And this really gets to the core of the book. Al-Khalili says that this understanding we've built through science, quote, is the only reliable way we have. It's our best tool, really our only tool for sorting out what just feels right from what's actually demonstrably real.
Okay, so what has this system actually revealed to us? Well, modern physics shows us a version of reality that's built on three gigantic pillars, and each pillar describes the universe at a totally different scale. Let's walk through them.
First up, Pillar 1. For this, I want you to zoom way, way out. We're talking cosmic scale. This is relativity. This is Einstein's turf, the physics of planets, stars, galaxies, and the mind-boggling fabric of space.
And relativity just completely blew up our old ideas about gravity. See, it's not some invisible force pulling things. No, Einstein showed us that heavy objects, like planets and stars, literally bend and warp the fabric of space and time, or space-time. What we feel as gravity is just us following those curves. It's wild.
Okay, now for the second pillar, let's pull a complete 180. We're going from the biggest things imaginable to the absolute smallest. This is quantum mechanics, the truly bizarre and counterintuitive physics of the subatomic world.
Down at this level, the rules are just different. In our world, a baseball is in a specific place. But in the quantum world, a particle, like an electron, exists in a weird haze of possibilities. It isn't definitively here or there. It's just a probability cloud until you measure it, and only then does it decide where it is.
So, we have the very big and the very small. Our third pillar is what connects them. It's thermodynamics. This is the physics of energy, heat, and most importantly, the flow of time itself. It's the reason your coffee gets cold but never spontaneously heats itself back up.
The secret ingredient here is a concept called entropy, which is really just a fancy word for disorder or messiness. The rule is simple. Things tend to get messier over time. An egg will scramble, but it won't unscramble. Your organized desk gets cluttered. This relentless, one-way street toward more disorder is what gives time its arrow. It's why we remember the past, but not the future.
So we have these three amazing pillars: relativity for the cosmos, quantum mechanics for atoms, and thermodynamics for the flow of energy. They all work perfectly in their own domains, but here's the problem. The biggest challenge in all of physics: they don't quite talk to each other. The ultimate goal is to find one single theory that unites them all, to complete the map of reality.
And this brings us to a really helpful way to picture this. Think of our understanding of reality as a layered map. Relativity is the giant atlas for the cosmic highways. Quantum mechanics is the super detailed street view of the microscopic world. Both maps are unbelievably accurate for their own territory, but physicists are still trying to figure out how to stitch them together perfectly at the seams.
But here's the kicker, the really humbling part. That map we've been building, all that incredible science, relativity, quantum theory, all of it, only describes about 5% of the stuff in the universe. The other 95%, we don't really know what it is.
We have names for these massive blank spots on our map, of course. We call them dark matter, the invisible scaffolding that seems to hold galaxies together, and dark energy, some mysterious force that's pushing the universe to expand faster and faster. And the search for quantum gravity is that ultimate quest to find the final theory that would finally connect all the known parts of our map.
So what's the big takeaway here?
It's that the universe is profoundly stranger than our everyday intuition can possibly handle. And that is precisely why we need a system like physics. It's a disciplined, evidence-based guide that we can trust, especially when our own senses and instincts lead us astray.
For the full, long-form deep dive into this book and its ideas, follow the link in the description. If you enjoy these explainers, please subscribe and comment with books or topics we should explore next.